Hi there. So as a first step, always when you're trying to find the volume of a surface of revolution, you want to indicate your region, the region that's being rotated about your given axis. And so I've gone ahead and sketched that region out just qualitatively so we have a sense of what we're dealing with. And I've highlighted the region in green. So our next step is to actually set up an integral. And what we know is that we're rotating about the x-axis, as I've indicated. And in general, when you're rotating about the x-axis, we know that we're forming a bunch of disks that we're stacking up along the x-axis. And so we just want to determine the area of these disks as our first step. So what I've indicated right here in drawing this line is that our disk has a radius extending from the x-axis to this value of y. Now, how can we determine this value of y? Well, the line right here is simply the equation y equals 5x squared minus 20. Note, though, that y in this case is negative, right? Our radius, however, is a positive quantity because we're looking for that overall length. And so we want to just be aware that technically we're taking the absolute value of this. In fact, however, this detail doesn't matter because we're trying to find the area of our disk. So if we spin this radius around the x-axis, what is the area of our disk? Well, it's a equals pi y squared. And so a is equal to pi times 5x squared minus 20 squared. So that's the area of each of our washers. And from where to where are we stacking up our washers? Well, we're stacking them up from the origin, so from x equals 0, up until our very ends where our graph intersects the x-axis. So we want to find the value of that. So we set y equals to 0, or 5x squared minus 20 equal to 0. Solving that, we get x squared is equal to 4, or x equals 2. So that gives us our bounds of integration from x equals 0 to x equals 2. And so now we can set up our integral. Effectively, what we're doing, just as a refresher on the disk method, we're saying we have a bunch of infinitesimally thin disks, and we're adding up their volumes. And so we have the integral from 0 to 2 of pi times 5x squared minus 20 squared dx. And that essentially is all of our problem. We can now go ahead and expand this and apply the polynomial rule if you'd like. So factoring out the pi, I'm just going to expand this polynomial. So we get 25 x to the 4th minus 200 x squared plus 400 dx. And now we apply the polynomial rule for integration. So that becomes pi times 25 over 5 x to the 5th minus 200 over 3 x cubed plus 400x evaluated from 0 to 2, assuming I've made no minor errors. And so now we just plug into the 0 term goes away. So we have pi times 5 times 2 to the 5th minus 200 over 3 times 2 cubed, which is 8, plus 800. And I will leave the remainder of this arithmetic to you. Thank you for watching, and I hope this was helpful. Bye.